Hello everybody. Welcome to this event with Keystone Lintels. I'm delighted to be here and chairing it. My name is Ruth Slavid and I am your chair for the day. And I'm really glad to be doing this because I think it's such an interesting subject. I think we're going to have a fascinating hour or so looking at future home standards. It's obviously a really important question, really important issue to look at because housing is at the forefront of all our minds. On the one hand, we have the government with its ambitious targets of 300,000 new homes a year. And on the other hand, we have this commitment that our homes will be, everything will be zero carbon by 2035. So the really big question is, how do we get from here to there with a lot of new homes? That's what future home standards are aimed to help us do. And we are going to look at the challenges of how we get there. Is this feasible? What does it involve? And we're doing that with three really great speakers. I will be introducing the speakers as we go through, but I just tell you very briefly first that we have got Gavin Dunne, who is playing a really key role in the Future Home Standard. We have got Darren Evans, who is a sustainability specialist, and we have got Ben Cheatham from Keystone, who also is looking at innovation in order to help this happen. So before I introduce our first speaker properly, I just want to talk to you a little bit about how this is going to work. As I said, we have got three speakers. We will have a question and answer session after they've all spoken, and we would love you to take part in it. So if you look, I think it's the right-hand part of your screen. It certainly is the right-hand part of mine. And you will see three things. One is chat. If you just want to make some general comments about how much you're loving this or whatever, do feel free. But if you want to ask a question, and my advice is when you think of the question, ask it because you'll forget it later on. Please ask it under questions. And the third thing you can see is polls. Now, when Darren speaks, he is going to put a couple of polls up and he would like a really quick reaction from you. So when he shows the polls as part of his presentation, do click on polls and make your response. So that's it for introductions. I think we're in for, as I said, for a really great hour. And all that remains to me now is to introduce our first speaker, who is Gavin Dunne, who is an experienced business leader. He's a chartered building engineer, and he sees his great skills, I'm sure he's right, bridging technical matters with effective business management. Specialises in building energy performance and low carbon design. And currently he's chief executive of the Chartered Association of Building Engineers. He's got a number of other interesting roles, including he is a member of the Building Regulations Advisory Committee, BRAC, of the UK government. And in that organisation, he is chair of the Future Home Standard Working Group. So there's nobody better really to start this event for us. Over to you, Gavin.
Good morning, everyone. Hopefully you can now see my slides. Thank you, Ruth, for the introduction. I'm Gavin Dunne, and for the last 3 years or so, it's been my distinct pleasure to lead the working group looking at the Future Home Standard. Now, this group is a group of industry experts, house builders, product designers, sustainability specialists, engineers, who have been brought together to advise and support and be a critical friend to government as they start on the journey of reforming our building regulations to make the homes fit for zero carbon. So we're not government, we're not speaking on behalf of government, we're there to advise and help them and nudge them along in the right direction. In particular, what we're talking about, this is about building regulations, as applied to new build homes, and the Future Home Standard is really a very significant shift in the current requirements for energy, so that's part L, but also F, ventilation, with the aim of bringing the Future Home Standard in 2025, which will be a very significant shift, but also regulations laid later this year for 2021, which will provide the industry an interim step towards that goal. It's important to note these specific proposals relate to England, but the group has been, and the work has been shadowed by representatives from the Scottish, Welsh and Northern Ireland authorities who are undertaking a similar process at this time. So first of all, Future Home Standard, what is it? Well, as I said, it's a change to the energy and ventilation requirements of buildings for new build homes. And it's got a number of key drivers. So first of all, it is about preparing our new homes to be fit for a zero carbon world, not zero carbon in 2025, but we're making sure our new build homes are built so that they are ready for that. In particular, it facilitates a very significant shift for the country away from a predominance or an assumption of using natural gas for heating of our buildings and start to make the transition over to electricity being the primary form of heating in homes. This is for two reasons. So first of all, we're looking over the horizon and we know that natural gas won't be around forever, but also it is a carbon-based fuel. And even though we can use it very efficiently, we know we can't get to the full zero carbon standards using gas. But also, and this is very, very good news for everyone, the electricity, UK grid electricity is decarbonising far faster than anyone, and certainly I had expected in recent years. And the forecast is that it will continue. And so by 2030, the grid electricity has potential to be very low carbon and clean indeed. So we've got a very significant shift to facilitate that. Other driver in the Future Home Standard, and this is why it became quite a big and complex package of work, we also wanted to address a number of areas I often refer to as unintended consequences within the building regulations, where we fix one problem but we inadvertently create others. There's a lot of evidence at the moment suggests that new build homes are at higher risk of overheating during extreme heat periods in summer, and that's actually starting to endanger lives, and a significant number of lives when you take into account the forecasts for climate change, where we're expecting increase in hot summer periods. But also, unfortunately, regarding ventilation, the evidence at the moment isn't good in terms of compliance with the current Part F, and there's lots of evidence emerging around large proportions of our homes being underventilated. So as we're improving the fabric performance and the building performance of our homes, we also want to address these issues to make sure that they are also going to keep the occupants safe and in good form of well-being, as well as in helping with good performance of the homes. So the headlines themselves, 2025, we are looking for about a 75% lower carbon emissions from our new homes. That's compared to Part L 2013. As I said, it's also about making the step in terms of decarbonisation, so the shift to electricity as the main form of heating. And key to this is very much an assumption, a presumption around fabric first. Key to all of this is getting the energy demands within a home as low as possible, and that's about getting the details and the insulation levels and thermal mass of the fabric correct, and then servicing those lower heating requirements with very energy efficient and low carbon sources. So hopefully it gives you a flavour of it. It's a very significant step in the right direction, but the big headline will be no gas. So the proposal is 2025, you cannot connect gas to your new homes. Because it's a big change, there's going to be an interim step. So very quickly, there will be an interim step which we hope to come into law late this year. And that is a proposal for a 31% shift in carbon, so approximately halfway to the Future Home Standard for 2025. Again, it's a fabric first approach, but with a bit more flexibility. You can still use gas, but if you do, you have got to, so if you're still using a gas boiler, you do have to put the measures in place so that the building can easily be switched over to a zero carbon source later. So for example, if you're using gas boilers, you'd need to put low temperature radiators in. That gives you a bit of efficiency advantage now, but also makes the switch over to heat pumps later on come through and easy. There is some cost to this, somewhere between £3,000 and £5,000 is the estimate per unit on average, depending what technology you get there. And there's a lot of focus on heat pumps because that seems to be the cheapest and most cost-effective way forward with technologies that are currently available today. So good fabric and heat pumps are clearly going to be a big part of this transition. Very quickly, because this is just a brief introduction, we are looking at a number of other key issues. So one is the performance gap. So this is something many of us in the industry have been talking about for some considerable time, where homes just aren't performing at the level that they're supposed to through issues around design, construction. It's very complicated. These regulations are going to start to address that. First step will be in 2021. There will be a big push around transparency and provision of information through to the end users so that things can be fixed. And we can find out why things have gone wrong later, with a bigger push in 2025, possibly with new technology looking at actually measuring the performance of homes in use after they are built. And then final thing from me, if you're a house builder designing the room, get ready, because this is going to start happening quite quickly. So first of all, 2025 isn't very far away, but also the way the regulations will be implemented, the transitional arrangements are changing so that no longer will you be able to get approval for a particular set of regulations on the entire site. It will now be building by building. So if you haven't started construction on the individual home within 12 months, you will have to switch to the new standard. So that's definitely one to manage if you're involved in the provision of housing at this time. Look forward to the debate. Well, I'm sure we'll get into lots of the bits and pieces, but for now, back to Ruth.
Thank you very much indeed. That's a really wonderful introduction, and I think it gives us lots to think about. I'm really glad I'm not in the business of making gas boilers. We've already got some questions coming in from the audience, which is fantastic. And as I said, more questions for Gavin or for other speakers, do ask them, and we will address the most pertinent questions. But now we are going to move on to our second speaker, Darren Evans, who is the founder of Darren Evans Limited. He's an expert in technical sustainability in the built environment, in helping the industry understand that there actually is more than one way to build a sustainable world. He provides a range of sustainability consultancy and services. Basically, he's helping people deal with all the changes, all the changing regulation, and how to do things better. And I think that's probably enough introduction, because I think he's a fascinating person. Just before I hand over, he is the person who's going to have the polls. As I explained to you, there is a polls tab. So when he gets to the poll, do please click on that tab and respond. Darren.
Thank you very much. Good to be here with you all. Let me just start here by saying that, absolutely what's been said before. I'm really looking to try and help the industry and individuals approach the whole sustainability question with far more, I guess, kind of ease than maybe what's happened in the past. So I want to cover these 4 areas. There are quite a lot of slides that I'm going to go through, and so we'll run through them at a fair, quick pace. So anyway, the question of net zero. I think, first of all, before we approach anything, we need to get our definitions correct. And so this is the definition which I am going by. I really identify well with this definition from the UK Green Building Council. And so that is what I'm approaching this session with. So for the industry, based on this definition, and essentially what we need to do is we need to look at the whole life carbon of the building, and this is built up in 2 main areas. One is the embodied, the other is the operational. So just to firstly cover off the operational, I think that there's mostly architects on this webinar, and I'm sure you'll be very, very familiar with the regulated emissions, which you'll see in your SAP and your SBEM calculations for building control mostly. This covers things that the government want to control. Those are heating, hot water, electricity. Now, the unregulated emissions are things that the government don't control. They don't control how many TVs I have in my home. They don't even control if I want to be a little bit geeky and get some automatic water feeder or something for my cat. They've got no control over that at all. And so it's important to understand and realize that we need to split these 2 out because they both feed into the overall issue. When we look at the way that emissions are addressed within the building, first of all, and this has been, I guess, taught and preached and applied in most places for a long time, we first need to look at, as Gavin mentioned, fabric performance. Then we start to go into areas that are slightly variable with how we deal with heat into the space and also heat into hot water. The section there on the top on the slide there, which I've entitled Allowable Solutions, is to enable us to get to this position of zero carbon in performance. We need to look at what are we offsetting. And so I've called this Allowable Solutions is because are we allowed to, or should we be allowed to offset everything? Should this offsetting happen under certain circumstances and in certain areas? And I think at the moment there's a big debate going on in terms of what that looks like and what in terms of allowable solutions is covered and is not covered. Above that, once we want to get really into this higher area or better area of the way that we address carbon within not just the country but across the globe, is how do we address and what do we do to look at this this unregulated energy piece. So that then brings me to my first poll. The poll should be up now. So just very quickly, this is completely anonymous. Which would you say of these low zero carbon technologies have the highest impact on operational carbon? Which would you say would have the greatest impact? So let's just have a look really quickly. If you can just submit your votes really, really super quick. So if we can just get those results published so that I can see those too. Okay, I can't see those at the moment. So let me see if I can. Okay, for the 90. Oh, here we go. Okay, great. So most people said fabric first. Okay, great, fantastic. That tells me with now a surety that most people on this call are architects, because that I'm sure is what's been drummed into architects for a very, very long time. Now, generally, the thing that makes the biggest difference are heat pumps. Yes, they are unsightly, maybe for some on the back of the house. And yes, we could be in a position like we were in Northern Ireland, where we didn't look at the fabric and all we did was put heat pumps in there because of other incentives, and things went terribly wrong. But this assumption that the fabric is of a good level or of a high enough quality, the thing that would make the most difference really is a heat pump. Why is that? Well, because when we look at this graph here, most of the element there is taken up in space heating via a heat pump. Also, the area that a heat pump covers is hot water. Often hot water is something which is overlooked, especially when we look at where our energy goes. But a heat pump covers both of those areas really, really well. Well, you might be saying, well, hang on a second, Darren, because we've got things like Passive House, and Passive House is really good because it's super efficient on the fabric. And I would completely agree with you. But this slide here just depicts that when you look at a normal house, which is there in blue, and you compare that with a regular standard passive house, which is in the gray color, when we start to look at delivered energy, the difference between having a normal heating system and having a heat pump as your system there in the passive house makes a considerable difference across the board. So as this is just a very, very quick illustration, I want to just press on very quickly, look at the definition of now the other element, which is embodied carbon. And so embodied carbon is something which is becoming more and more prevalent now. There was a news piece just in the BBC today with reference to demolition, and a concern being about how that affects the embodied carbon within that demolition process is released. And so, just another quick poll: what would you say, kilo for kilo, which of these materials have the highest or the higher embodied carbon? So super quick on the responses, if you can. Again, there is an opinion or a right answer, should I say. So let's close the polls off now really quick. Looks like here most of the people on this webinar are going with cement. Funnily enough, the thing which is the answer to the question is solar photovoltaic. The amount of carbon that it takes to create a solar photovoltaic panel is huge, but, and this is the bit that needs to be taken into consideration, is across the lifespan of the panel, it actually decreases carbon emissions in other areas. So the photovoltaic panel over the course of its life can actually do far better, depending on orientation and the way that it's used on the building. But I just wanted to make the point that in terms of creating the actual panel itself, it's very high. But what we get is the benefit is that it actually generates or generates energy and saves carbon in other areas. The one that is the worst, without doubt, is aluminium cladding. There is no benefit in using aluminium cladding when we look at the environment for aesthetics. I appreciate that aluminium is used in other areas for other reasons, but when you're looking at aesthetics, if you're using aluminium cladding, you really are making a poor choice there. So 5 quick takeaways there. I will just leave for you because my time is really short. First one, if you don't need to build it, please don't build it, because that is really that's the best and the first and most important way of reducing the impact of carbon on the environment. Second one there, with reference to aluminium, don't just use it for aesthetics. It needs to be far more purposeful than just the aesthetics. Reduce the amount of concrete used in foundations. I see that in the poll, lots of people believe that that was the greatest emitter. Yes, it's a considerable amount of CO2 is released. There is a new technology called LC3. Some of you may or may not know about that, but what that's looking at is the reaction of the chemicals coming together and how those chemicals actually reduce the amount of CO2 that's emitted in the atmosphere. We know about plant-based, but I guess the overall way to start to reduce things really is to design and plan initially for things to be reused later, so that we can keep that carbon locked in that house. That is it for this whistle stop tour, but thanks very much for your time, and back to you, Ruth.
Thank you very much indeed. As I said, we are going to be taking questions at the end of all 3 presentations, but I just wanted to mention that somebody has asked a question about whether the slides will be available to view afterwards. And actually this whole event is being recorded and will be available, and I'm sure it'll be on YouTube on the Keystone channel, but I think you will all be sent a link to it. As I said, I'm keeping all the other questions until later. I mean, thank you very much for those polls. I answered with a majority, which meant I got both of them wrong. I know aluminium's light, so I suppose it's a weight for weight thing, isn't it? Anyway, we are now moving on to our final speaker, who is Ben Cheatham, who is National Specification Manager at Keystone Group UK. His background is in engineering, started as a technical engineer. He studied civil engineering. He's been with Keystone for more than 9 years. And he manages the specification team supporting architects, specifiers, and national house builders. So over to you, Ben.
Thank you, Ruth, and good morning, everyone. Thank you for joining us today. It's great to be here. So over the next 7 or 8 minutes, I'm really going to be looking at the fabric first approach in a little bit more detail, as we've heard from our brilliant speakers today. The fabric energy efficiency standards will be remaining as a key performance metric. And, you know, I know it's been sort of put in place over the last few years and really hammered home to people that it's a really efficient approach. So I thought I'd look at it in a bit more detail because getting these details right first time round early in the design stage will really be at the heart of helping house builders and specifiers comply with these latest regulations. A key element of Fabric First is addressing thermal bridging. So I'll also cover thermal bridging in a bit of detail. And with steel lintels generally being a key thermal bridge in any building, I'll also just look at what difference lintel specification can have in SAP as well. So as I'm sure we all know, every building will produce carbon emissions because it uses up energy to heat, light and ventilate the space within the building. The heat is then lost through the roof, the wall, the floors, the windows and doors, which is referred to as the fabric or the external envelope. And the Fabric First approach is rather simple in principle. It's really about carefully considering the design and the construction of the building's envelope in the initial design stages. And the idea is by using high performing materials and also adapting the principles of air tightness and ventilation, you can really minimize the amount of heat that is lost in the first place and therefore reduce the amount of energy required to heat up the building and obviously lowering your carbon footprint. So it's in simple terms, that's what it's really all about. And within the external envelope, there are lots of additional junctions where heat can bypass the insulation layer, and collectively these junctions are known as thermal bridging. So thermal bridging, it's nothing new. I'm sure everyone's aware of it or heard of it. The BRE actually did some work into thermal bridging several years ago, and they found that up to 30% of a typical dwelling's heat loss can be through thermal bridging alone. So it's quite a significant amount. So what is thermal bridging? Well, in simple terms, it's anywhere in the building where there's a more conductive material or maybe a gap in the insulation in that external fabric or the external envelope that really forms a bridge between the warm inside and the cold outside and provides a clear path for the heat to escape and be wasted. So thermal bridges fall into really two categories, non-repeating and repeating. So the repeating thermal bridges are any material that really interrupts the insulation layer in a really consistent and predictable way. So if we think about steel wall ties in traditional build or timber studs like we're shown here in timber frame, they're all taken account for in the overall U value for that particular element that they sit within. And it's the non-repeating thermal bridges that really have to be addressed separately. So things like where building elements meet, so where the wall might meet the roof or the floor. And I know we're maybe a bit biased being a lintel company, but the lintel example we've got here is actually a really, really good example of a thermal bridge because it bridges the cavity and it acts as a clear path for the heat to escape because number one, steel is very naturally highly conductive and lintels generally span over long lengths. So for that reason, that tends to be why they're one of the worst thermal bridges within the builds, or one of the key ones really to look at and address. So the primary function of a steel lintel is obviously structural, and obviously in doing so, it's leaking out as a thermal bridge, and we can sort of see that in this thermal image of typical house here. And when we talk about thermal bridging in SAP calculations, we're really looking to improve the construction around these details to really stop or eliminate the heat escaping and obviously therefore save energy. So those really, I know we're limited on time, but they're really the simple principles of Fabric First and addressing thermal bridging. So we're sticking with the lintel junction within SAP. One way to virtually eliminate the thermal bridging would be to specify a high therm style lintel. So this is something we have developed in the world of lintels to really eliminate that thermal bridge in steel. So high therm lintels work in the same way as standard steel with one major difference. And that you can see we've introduced a second material. So this is a rigid polymer isolator that isolates the two leaves of galvanized steel and creates a really powerful thermal break. And as you can see, it really stops that heat from bypassing the insulation layer and really eliminates that key thermal bridge within the building. So some of the key benefits of the actual lintel are it's installed in the exact same way as a standard one. When we designed it, we really wanted, a smooth transition for site teams and installers. So it's installed in the same way. It's been designed and tested to support the same loads as a standard one, so same length, same structural capacity, same cavity sizes, and crucially, it's around 5 times more thermally efficient than a standard. And I'll come on shortly to Psi values and why they're important and what difference they can make in SAP. But typically the high therm is around 5 times more thermally efficient, and also it's been fully BBA tested as well. So just looking at the Psi values, these are what makes all the difference within SAP calculations, and this table shows what values are available for steel lintels. And yeah, to really design efficiently in Part L, it's really important today to use independently calculated Psi values by trained people. So people like Darren and his team, manufacturers will do bespoke accurate Psi values now, and you're always going to get the best result in your calculations if you're using accurate values. So the default value is 1 for steel lintels. I'm really hoping no one's using 1 because it has a really detrimental effect. And the standard steel Psi value for standard usual steel lintels is 0.23. There are some accredited construction details for steel lintels. They're actually being removed from the next round of SAP because today, even they're outdated, and calculated values are so much significantly better. Yeah, they're being removed from the next round of SAP as well. And with the high therm, you can see we can get it as low as 0.03. So you can see it's significantly different, lower, and that's what can make all the difference within SAP. So really poorly performing products and materials are increasingly penalised. So if you don't address these details, and I'm showing you the lintel junction, but there's lots of other junctions, really looking at the details and really trying to improve them, it's going to go a really long way to help you reduce your build costs and not spending extra money elsewhere in the spec unnecessarily. So just to reinforce what actual difference this makes, this was a SAP calculation that we took from a typical 3-bed detached house, and we can see there was about 13 meters of lintels on the total property, and initially they had put the ACD value of 0.5 in for lintels, and at this stage the house type was failing, the dwelling efficiency rate was lower than the target by just over 2%, and it was actually failing. And we just wanted to highlight what different Psi values make. So by putting in the high therm of 0.05 without changing anything else, we can see that now this house type is passing. So we just wanted to highlight, look at the detail. These little details collectively, they can add up to quite a significant amount. And just to remain impartial, obviously to eliminate the thermal bridging problem, you could, go back to the old way of doing things, which is really to use 2 separate lintels, which, as I said, ticks the thermal bridging problem, but it does come with a number of buildability issues, which is another key thing because there's a number of knock-on effects to doing this. Additional materials required, so cavity closers, propping would be required for single leaf lintels such as that during installation, which is another cost in the process. Extra work for the guys because they're double handling, cutting insulation, and so a lot more of a knock-on effects to specifying that, to think about. And when you compare it to traditional sort of high therm lintels, a lot of the time it becomes more cost effective anyway, once you've added in all the additional things. So I know we've whizzed through that with limited time today, some big topics, and thank you all for listening, and back to you, Ruth.
Because we are now moving on to our Q&A session. That was absolutely great, Ben. Thank you. And I think it's so important that we understand that it's not, we have to have all the theory right, but actually we have to get all the details of the building right. So I can see that Gavin's back with us, and if we can have, yes, Darren and Ben back on the screen as well. Ben might be having a technical problem, but anyway, I'm going to start. We've had questions sent in by people, which is fabulous. It shows how engaged you all are. Before I actually put a question to any of our speakers, somebody has asked about CPD certificate, and the answer is yes. If you do want one, do request it, and it can be sent out to you next week. There've been quite a lot of questions around the subject of heat pumps and how they work with hot water, whether there is a heat lag. I know there's also a question, isn't there, that heat pumps are not necessarily designed to get temperatures up to the sort of temperatures we want for our hot water. I know I'll be corrected if I'm wrong. And other questioners have been asking about cost, how we're going to cope with the additional cost, and also whether our electricity network is robust enough to actually cope with the extra demand put on it, which I know is a subject around electric cars as well, which is not what we're discussing. And there's a concern about how ugly heat pumps look sort of put out in gardens or wherever they are. And I know there have been people questioning noise as well. So that's a lot of questions I'm throwing at you around heat pumps. And I think probably that both Gavin and Darren are going to have something to say about that. Shall I start with you, Gavin?
Yeah, sure. Yeah, that was an awful lot of questions.
I know. And if you forget a bit of it, you're forgiven and I'll prompt you.
But halfway through, I remember to start writing them down. I think I would give a more broader perspective around the heat pump piece. So heat pumps are an important part of the technology mix to achieve this. But they're not the only technology. And obviously there's different types of heat pumps. And the reason it's come into focus is the analysis suggests, certainly for the 2021 interim standard, the heat pumps becomes quite one of the more cost-effective and arguably easier routes through to compliance. So I'm going to reflect on three high-level matters on that. The first one is, unfortunately, the culture in the industry is still that the minimum building regulation standard, because that's what we're talking about here, is still the thing we aspire to and don't aim to go above and beyond. We are talking about minimum expectations here. I think the second thing I'd say about the heat pump, particularly when it comes to domestic hot water, this is part of a much bigger shift. And certainly by the time we get to 2025, if the fabric is performing at the levels that we're going to be specifying, domestic hot water is going to be your biggest energy demand, certainly for heat. So actually, you'll be designing systems 2025 for your hot water demand, not the heating demand.
Yeah.
I can see how in 2021, there's going to be more of a mixed space. And then the other issue with heat pumps, I think, is there is concern about the spin up. If we are become very dependent on heat pumps, as there's a massive capacity and skills issue in the industry, and that's on both sides of the fence. That's both with the builders and with the people installing, supplying heat pumps. There is absolutely, we need more people skilled to install, commission, design heat pump systems, but we also absolutely need to ensure that the builders understand that this isn't just about build a house who've always done it and bung a heat pump on and it will be okay. You're going to have to pay much greater attention to the fabric. These systems only really work effectively. In other words, they don't let your customer down, the homeowner, the future occupant, if the fabric works. But also the heat emitters need to be designed much more carefully. So there's going to be a much greater need, irrespective of whether you go with a heat pump or not, to focus on getting the fabric right and getting heating system design right, and then actually ensuring that is built in practice. Otherwise, you're going to have some pretty unhappy customers. And because it's electricity, it's great, it's getting lower carbon, but it's still quite an expensive fuel. Yes. If you don't get it right, you get customers with very high energy bills. So there are some risks here. But it's an important part of the technology, particularly in the transitional phase.
Thank you. Darren, you've been nodding a lot, so I'm sure you agree with what Gavin said, but is there anything extra and different that you'd like to add to it?
Yeah, the only thing that I would add really is the point that Gavin made with reference to there being a silver bullet. I think in the society that we live in at the moment, it's very easy to slip into, I just need this pill and that'll solve my problem. I just need to Google this question and the response will come back and my problem is solved. Construction is complex. There's lots of moving parts to it, and there isn't just one thing that you need to put in. I know that I said in there that in terms of the impact, it has the greatest impact, but I hope that I don't come across as saying, I'm flying the flag saying that the heat pumps are the silver bullet, because that is completely not what I'm saying at all. And I hope that you don't take that away. But not really would I say that about heat pumps. I wouldn't say that about fabric. I wouldn't say that about any element of the building. And maybe if I can draw an analogy with the body, if I've got a problem with my ankle, then my knee's probably going to be affected, my hip and my back are going to be affected, because everything moves in line. And so just like the building, it depends really what the best solution is. And so that's why you need to go to see somebody that has a more holistic view of something, instead of narrowing your focus, looking for that magic pill or for that silver bullet. And that's the approach really that we need to take when addressing the situation with carbon and trying to reduce it and remove it. This is more of a journey, as opposed to some intelligent person somewhere has got the answer, and we just need to find that person and they'll tell us what to do.
Thank you. Well, here's a holistic question then. Somebody's asked, fabric aside, wouldn't there be much to gain by moving away from detached executive style houses to smaller terrace designs? You don't lose as much heat through the party wall, do you? Yes, no, you don't like that.
Oh, is that to me?
Well, it's to whoever'd like to answer it, yes.
I'll put it this way. I mean, I think the point being is, there is an element of consumer demand here. And one of the drivers is demographic changes, where we are living in smaller household sizes and expecting far greater expectation in terms of space and amenity within those homes. Certainly, I don't think the government is certainly going to get into the world of regulating that. But what we would like to see is the performance of those homes start to also meet those requirements. And hopefully the consumer expectation will be not only are these homes big and got all the nice things they like, but also perform and are zero carbon. And that relates back to, I think there was a question earlier about cost. None of this comes without cost.
Thank you.
I think sorry to just jump in there, but I think the other thing is with that cost is it comes down to value. It depends what it is that you really value. If you value a house which is in the middle of nowhere and it's absolutely huge and you've got an internal pool, well, then that's what you're going to desire and drive, towards. But if you're in the middle of a desert and somebody gives you some water, then the value of that is far greater than gold. And so it depends on the situation that the individual or the group find themselves in. But what I do know is that when we live really, really close together, then that has impacts on society maybe that we don't want. And it has, or it could have impacts in other areas, maybe really, really good for CO2, but not necessarily good, for people's mental health. If the space is too small, if you've not got areas where you can go and walk, or the sound, there's other factors to that, but we can't all live in a tent.
Oh, great. Ben, you're back. I know you're having technical issues and we lost your video, but I think even if you're not there on video, you can still speak to us. We've had a couple of questions directed specifically at you. I think some are very, very technically specific questions, and I'm sure that you will be happy to answer them to the people who've asked them. But there's somebody here who's asking about the Psi value you gave for standard lintel and saying, is that for an insulated lintel?
Yeah, so I'm not sure, I hope you can see me and hear me.
Yeah, we can. And I think even if we can't see you, we'll hear you. Okay.
Yeah, so with the standard typical steel lintels, it is around 0.23. They do have the core of it's insulated with typically expanded polystyrene, but the steel, the heat will still bypass, as a thermal bridge, because it just travels around the steel. So yes, they are insulated, but it's only the high thin lintel you can get down to the really, really low Psi values of around 0.03 to 0.06.
And obviously lintels are pretty much the centre of your working world. But stepping back a bit, how can something as small as a lintel really make such a difference to a building? How important is that?
Yeah, so they are just one aspect of the overall building. Completely get that. They're a small but obviously critical part, because not only structurally, but as I've demonstrated, because they span over long lengths, because steel's really conductive, they're a really key thermal bridge. And I think just touching on what Darren said, there's no silver bullet, and it's the same. We're not sort of saying, look, lintels are the one solution that's going to solve all the problems. It's collectively looking at all these details. Some of them might be small, but collectively they all add up and they all can contribute and make a really, really big difference overall.
Darren, you know, a lot of this is really important for new homes. I know that Future Homes is dealing with new homes, but what about our existing housing stock? You know, there's an awful lot of it. However many new homes we build, there's still going to be a lot of existing homes, and the last thing we want to do is knock them all down and replace them. So how are we going to improve our existing homes? How big a challenge is that?
Yeah, so I think it's a significant challenge, and I think that that may be, as far as the mainstream media, something that appears to be overlooked, especially within the housing area. I think kind of using the same principles as we do on new build as we do in the existing are still very, very relevant. First thing is we need to look at the fabric. What is the fabric like of the existing properties, and how can we improve those? How can that be addressed? And secondly then is looking at the way that we heat the space and also the hot water, because those two fundamental areas, or three areas, are the same whether it's a new build home or an existing property. And then the last thing that I would mention then comes down to value. Is there incentives that the government offer, and can the government offer more incentives to people? Or do you and I value a lower carbon emitting home as one over one which is higher emitting? Would I be willing to effectively, through my choices, drive the price up of that type of property? Or am I really interested in just buying something for as cheap as possible because I just like the view outside? So I think that there's a number of things that we can look externally and say, yes, the government's responsibility is to do that, it needs to do this. But I think that ourselves, we can control what we do ourselves. And so if we look at, okay, what can I do to impact it and influence it? Or we can decide on the things that we go and look for, and by virtue of that, we drive the value up and start to push things in that direction.
Okay, Gavin, I'm going to come back to you, and I'm going to give you another lovely portfolio question. First of all, we've had a question come in, and we're going back to heat pumps for a second. We've had a question about the water temperatures that can be achieved using heat pumps. And then moving on from that, you know, we've been talking about heat pumps, which are electricity. Obviously, we've been talking about gas, which is what we've been using widely in our homes up to now. What about hydrogen? Does hydrogen have a role to play? But first of all, can I have a nice hot shower if I get a new home?
Yeah, so look, I mean, it is one of the limitations of the technology in that heat pumps work most efficiently when the temperature lift between the ambient outdoor, where it's drawing the heat in, and supply temperature is low. And that's why the heat pumps are normally used in a heating application with low underfloor heating or low temperature radiators. Yeah. Because that's where they get the optimum efficiency. They can go up to higher temperatures, but they drop a bit of efficiency. So the sort of temperatures you would need on a low temperature radiator, say 55, 50, you'd probably want 70 plus, 75 for your domestic hot water. My family seems to want about 80, but they're obviously made out of asbestos. So the heat pump can do that, but it is not as efficient in providing the domestic hot water. And hence the controls around the amount of use is key, but they can do it. And often systems will have a two-stage system where they might use a little bit of direct electricity to top up or other forms of heat. Mm-hmm. Cylinders and thermal stores can be very useful in this, where heat pumps run at a low level all the time, and you're maintaining thermal stores with different temperatures, so you can pull off both the lower grade heat for the heating, but also the higher temperatures. And those can be very nicely topped up with other forms, including solar. So, you know, I know one of the things people are using is diverting PV. If you've got it, if you're not able to get back to the grid, get it into an immersion heater to top up your hot water cylinders into the higher temps. So there are solutions out there. So again, it comes back to this. It's a system. It's not just a you know, it's not just a silver bullet, one size fits all, and all your problems have gone away. It's about having a proper system that is designed to work in this specific home for the fabric performance within it. Your second question was around hydrogen. Mm-hmm. So hydrogen in the longer run has a role to play, but you know, it's not going to be mainstream in most new homes anytime soon. So I think there's three things you need to be aware of here. So first of all, there's where you get the hydrogen from makes a big difference of how low carbon it is. If you're making it from fossil petroleum, it's still a fossil fuel in my mind, but you can make it very green. There's a big difference between green and blue hydrogen. Hopefully in the longer term we'll have fully green hydrogen at scale. Clearly that's going to have a big impact in transport, and we might see, and we've got some areas of the country where they're starting to use put hydrogen in the ground in terms of local infrastructure. Interesting enough, for existing homes, we haven't touched on that yet. No. Can actually mix about 20% hydrogen into natural gas. So, and most modern boilers can operate up to about 20% hydrogen mix. So if you want to reduce rapidly the carbon emissions of all homes, even if they've got legacy gas in them in, say, 10 years, 15 years time, starting to introduce hydrogen as a mix is one of the things that's being looked at. But we are talking really big government decisions here about national infrastructure. And they've just, decisions have to be made.
That's great. Thank you. Now we're going to move on to the final part of our webinar. And therefore, I am going to move away from Gavin and Darren and from Ben, who unfortunately can't be here, because the last part we are going to be talking to Derek McFarland, who is the MD of Keystone Lintels, and I'm just going to be having a chat with him because I think he's got some really interesting things to say. So I'm just waiting for a moment. Here he comes. Derek, welcome. Thank you very much.
Oh, yeah.
Hi. Now, obviously, people have not been submitting questions for you, so I've got some things to ask you. And the first one is, that the new Future Home Standard should ensure that all new homes built from 2025 will produce 75 to 80% less carbon emissions than the ones under current regulations. I mean, do you think this goes far enough? And will it have the teeth to make sure it delivers what it says?
Well, listening to the debate there and the questions that the guys are answering, it seems very, very ambitious. The current climate to go to the 2025 to the Future Home Standard. So I do think it is ambitious, Ruth. Certainly all the talk about the infrastructure and the decisions that have yet to be made, and we're such a short window away. So it's a big step change. I think the first step change coming out in the 2021 regulations, getting to 31% saving, I think will give us a taste how easy that is to achieve early on. So I'm confident. It's very ambitious, but I think first step will be okay. The second step will be a big leap.
Yeah, and of course, we're talking at one stage we're trying to build all these homes. At the other, we're actually trying to be net zero by 2050. I mean, again, do you think we can get to those targets
by 2050? 25 years, I'll be quite held.
Well, I'm not sure any of us are going to be working all that hard or all that involved, but we have to look to the future.
300,000 houses itself, Ruth, is going to be a challenge.
Be good for you.
Yep. No, it was certainly good for us. Good for all manufacturers. Good for the economy and industry, and I guess it'll create more innovation on bringing the modular. We know modular housing is going to contribute to a chunk of that.
And that you feel is because is that necessary because we haven't got enough skills out there in the sort of traditional building industry?
It'll close the skills gaps, and obviously with the recent between Brexit and the COVID pandemic, we naturally have a skills shortage right at this moment in time, as well as supply chain issues. So there are things that we maybe hadn't planned for, that we as a business have to now put into our risk management plans going forward. And obviously, if you can make some components, it might not necessarily be all full houses, but it could be more off-site components coming together on site, as well as the traditional build. And obviously, that's what people are familiar with, so that's important. But of course, that's all in the new build sector. It's something you can change easily, or more easily, I should say. Yeah.
Well, that's where I was going to come to, which is what about existing homes? We've talked, obviously, Future Homes covers the homes that will be built in the future, but existing homes both need refurbishing, and also, as we know, they're continually being altered, added to, etc., etc. I mean, what do you see as the challenges there?
Slightly different challenge, because we're talking about 300,000 new homes, but we're talking about, what's it, 45 million existing homes. So it's quite a huge challenge on how to do that. I don't see any evidence that that's been even considered. I hear Gavin talking about the mixing the hydrogen, which would be a good step and helping lower that. But I think the quality of a lot of the existing stock or existing housing anyway is in debate. So something drastically has to happen to make a step change in that, and how you then go about making a change and renovating it and stuff. So it very, very difficult.
And you do need skills on the ground for that, don't you? You know,
completely different.
Modular construction's not going to work, is it?
Not going to work. Not to try to recycle the existing house, because that's what you want to do. You want to recycle it by bringing improvements to it. So I know there've been different schemes in the past that have come and gone, but
some more successful than others.
Some more successful than others. So I guess if people use the word transition there during the presentations, and I guess that's what we have to look for. It's transition. It's finding that solution. And there's a lot of experts out here in the world, so I think working together we should get there.
Well, I'm going to bring you back to Keystone Lintels now. I mean, Ben gave us this great presentation showing, you know, how you have done product innovation, and you're really trying through that to improve the thermal performance of homes, and also in a way that is as simple as possible to install, which is important because we've talked about skills gap, etc. You even use the B word, Brexit, but we'll move on from that. So I guess the question is, you know, with all this coming, with all this ambition, where do you see yourselves going next? What are you looking to develop next, or is that a state secret?
Well, innovation is in our blood. Ruth, we're a relatively young company, 30 years old. So we've been innovating from the day we started manufacturing construction products. So we will continue innovating. Our high therm lintel was innovated 10 years ago, and it won House Builder Award 2 years in a row. We couldn't get the regulations to come fast enough. So we are certainly innovating. We're looking to continue to develop that. I noticed some of the questions coming through, some tricky technical questions on structural lintels and how we big openings and thermal bridging. So we still have a lot of work to do on the innovation within the lintel world as well, and that will continue. And of course, we are, as the Keystone Group, we're also looking at developing our key house that we can, that's our next state secret, if you like. Don't tell anybody.
No, I won't.
I
mean, you know, there's 200 odd people who are watching this presentation, won't tell anybody either.
So that's what we're aiming to do, and we're obviously we've got the smart roof business, which is modular room in the roof at the minute, which is fantastic for the beginning of modular and thermal performance. So we now go try to bring a whole superstructure to the industry. So that's the next aim, as well as developing component products that can be done off-site, can be set in. So we're continuing to innovate, Ruth. So
great. And I mean, you mentioned that there have been quite a lot of quite specific questions that have come in from the audience. Obviously, you and your colleagues are going to be answering those directly back to those people, aren't you?
Absolutely.
And if anyone else has any questions and they want to know any more about this, I'm sure I'll ask you the question. Can they contact you, and will you give them the answers?
Absolutely. No, we're more than delighted, because look, we need people challenging us, and we will do our best to come up with a solution and work with the details that everybody has, because each building is slightly different.
That's great. So obviously, just addressing the audience now, this will be available to watch again. You will get details, and that's either for you if you feel that there's something you've forgotten or something you'd like to catch up with. Also, of course, if you have friends and colleagues who you feel will benefit from seeing this, then do invite them to do so. I think the facility to watch things afterwards is a fantastic one, although I have to say I don't think there's anything that actually beats being part of a live event. So really, I think it just comes down to me to wind this up. Derek, that was a fantastic finish. I'd also like to thank all our speakers who were here. I'd like to thank you as the audience, both for your questions that you sent in and also for the fact that I knew you were there even though I couldn't see your faces. So on behalf of Keystone Lintels, I'd also like to thank Keystone Lintels for making this happen. It's been I said at the beginning it would be really interesting. Even so, I think it's surpassed my expectations. Lots to think about. So I'm going to let you go away and think about it now. Thank you very much indeed, and goodbye.